spiral galaxy. This is perhaps the most iconic type, with a flat, rotating disk of stars, gas, and dust, and a bright central concentration called the bulge. Winding through the disk are prominent spiral arms, which are regions of active star formation. Our own Milky Way is a spiral galaxy. They are classified by how tightly wound their arms are and the size of their central bulge, ranging from grand design spirals with well-defined arms to flocculent spirals with a more patchy, woolly appearance. Barred spiral galaxy. A variation of the spiral, this type features a central bar-shaped structure made of stars, with the spiral arms extending from the ends of the bar rather than from the core. Observations suggest that more than 2/3 of all spiral galaxies, including the Milky Way, are actually barred spirals. The bar acts as a kind of cosmic funnel, channeling gas and dust from the arms inward toward the galactic center, which can fuel star formation and feed the supermassive black hole believed to reside at the heart of most large galaxies. Elliptical galaxy. Ranging in shape from nearly spherical to a stretched-out football, elliptical galaxies lack the intricate structure of spirals. They have no discernible spiral arms and very little gas or dust, meaning that star formation has largely ceased. Instead, they are filled with older, redder stars that orbit the center in random directions. They can be tiny, containing just a few million stars, or they can be giants, among the largest galaxies in the universe, often found at the centers of galaxy clusters. Lenticular galaxy. This type serves as a kind of bridge between spirals and ellipticals. Lenticular galaxies have a central bulge and a surrounding disk, like a spiral, but their disk is smooth and featureless, with no spiral arms and very little ongoing star formation. They are essentially red and dead disk galaxies, having used up or lost most of their interstellar gas. They may have once been spirals that were stripped of their gas by the gravitational forces within a dense cluster, or they may have merged and simply aged. Irregular galaxy. As the name suggests, these galaxies have no recognizable regular shape. They lack a distinct bulge or disk and often appear chaotic, with a messy distribution of stars and gas. This chaotic form is often the result of gravitational interactions or mergers with other galaxies. The large and small Magellanic Clouds, visible from the southern hemisphere, are famous examples. Because they are rich in gas and dust, irregular galaxies are often sites of furious, widespread star formation. Peculiar galaxy. This is a catch-all category for galaxies that are unique and don't fit neatly into the standard Hubble classification. Their odd appearance is almost always the result of some violent or disruptive event. This includes galaxies in the process of colliding, those with strange jets of material streaming from their cores, or ones that have been tidally warped by a close encounter with a neighbor. The famous Cartwheel Galaxy, with its ring-like shape, is a prime example. Its form the result of a smaller galaxy punching straight through its disk. Dwarf galaxy. These are small galaxies composed of perhaps a few billion stars, a tiny number compared to the hundreds of billions in the Milky Way. They are the most common type of galaxy in the universe, and they often orbit larger galaxies like our own. The Milky Way has over 50 known dwarf galaxy satellites. Their small size and dimness make them difficult to observe, but they are crucial for understanding dark matter, as they appear to be overwhelmingly dominated by this mysterious substance. Seyfert galaxy. This is one of the two main types of active galaxies. A Seyfert galaxy looks like a normal spiral at first glance, but its core is extraordinarily bright, sometimes outshining the entire rest of the galaxy. This intense radiation comes not from stars, but from superheated gas spiraling into a supermassive black hole at the galaxy's center. They are essentially a lower energy version of quasars and help astronomers understand the violent processes that occur in galactic nuclei. Quasar. Short for quasi-stellar radio source, quasars are the incredibly bright and distant cores of active galaxies. They are powered by supermassive black holes, millions or even billions of times more massive than our Sun, consuming enormous amounts of gas and dust. The friction and gravity in this accretion disk heat the material to such extreme temperatures that it outshines all the stars in the galaxy combined. Because they are so luminous, they can be seen from the very edge of the observable universe, offering a glimpse into the universe's distant past. Blazars. Blazars produce light across the electromagnetic spectrum. Their powerful jets point almost directly at Earth, so they appear brighter than other active galaxies. Observatories on Earth can sometimes detect high-energy particles, like neutrinos, produced within the jets, and trace them back to their home galaxy. This information gives scientists a glimpse into the environment around the blazar's supermassive black hole.